Imagine trying to understand a complex machine where half the parts are hidden, and you cannot tell what each component is doing. It would be incredibly frustrating and difficult to fix when something goes wrong. This challenge mirrors a critical aspect of modern software architecture. Transparency is profoundly important in distributed system design because it allows individual components of a system to operate and interact without knowing the exact physical location or implementation details of other parts. This abstraction is fundamental to building resilient, scalable, and manageable systems. The core reason for this lies in managing complexity and promoting reliability. When a system is transparent, a request from one service to another can proceed as if it were a local call, even though it might traverse networks, cross data centers, and involve multiple intermediary services like load balancers or message queues. This conceptual simplicity masks the intricate network interactions and potential failures. Without transparency, developers would need to account for network latency, node failures, and data consistency issues at every service boundary, leading to an explosion of complexity and error-prone code. Transparency enables engineers to focus on business logic rather than distributed infrastructure plumbing. To achieve transparency, designers employ various techniques. For instance, remote procedure calls, or RPC, make remote service invocations appear like local function calls. Service discovery mechanisms automatically locate and register services, allowing clients to find them without hard-coding network addresses. Furthermore, consistent hashing can distribute requests across a cluster of servers, making the underlying server topology invisible to the client. An interesting nuance is the distinction between location transparency and access transparency. Location transparency means a service can be accessed without knowing its physical network address. Access transparency means that local and remote access mechanisms are identical for the developer. Achieving both helps abstract away the distributed nature of the system. This often involves middleware layers that handle communication protocols and error handling behind the scenes, creating a seamless experience for application developers. Ultimately, prioritizing transparency in distributed system design leads to more cohesive, easier to debug, and more adaptable systems. It empowers developers to build complex applications by focusing on their functional requirements, confident that the underlying infrastructure will manage the distributed complexities, making growth and maintenance significantly smoother.
If this helps you code smarter, like, subscribe, and stay tuned for more.